Greetings, everyone. My name is Rodrigo Burgos. I'm from the Rio de Janeiro State University, and I'll be presenting modeling of the P small delta effect using interpolating functions. The other authors are Luis Fernando Marta, Marcos Rodrigues, and Rafael Rangel. This work is partially supported by CNPq and FAPERJ. A summary of what this presentation will discuss. First, a brief introduction, talking about what is this P small delta effect, differential equations and interpolating functions used in this work, additional features implemented in Ftool, some examples, and later some conclusions. So what is this P small delta effect? When we look at the deformed configuration of a bar, we can see that there is a big delta, the top displacement, which is normally associated with global effects or nodal values. And there is also what we call the small delta, which is associated with local effects, some things that occur within the bar and that are related to the curvature of the bar. So if we use small displacements hypothesis, then the bending moment caused by the load P acting upon displacement delta can be neglected. This is what we call first order analysis. In this case, the bending moment has a linear distribution whose maximum value is the lateral load multiplied by the height of the column. And this distribution is highlighted in the figure on the right. When the bending moment caused by the P delta effect is not neglectable, it needs to be considered. Normally, a linear distribution is assumed with a maximum value given by the first order moment plus the P delta, the P big delta in this case, contribution, which is highlighted also in the right of the screen. Since the deformed configuration of the bar is not a straight line, as we can see there, linear distribution is not the correct approach within the element. And then the difference between the linear distribution and the exact one is what we call the P small delta contribution, which is also highlighted there on the left side on the right side, sorry, of the screen. When we solve the differential equation associated with this phenomenon, which we show later, we arrived at the following analytical solution in terms of displacement and bending moment. So we have here the expression for the top displacement, the expression for the bending moment in any point y through the height of the column, and the expression for the bending moment at the base of the column. Differential equations and interpolating functions. When we look at the infinitesimal element and we impose equilibrium and choose a beam theory, we arrive at the fourth order differential equation, which is shown there. The homogeneous solution of this equation is obtained by setting the distributed load to 0 and considering a parameter mu for a compressive force. And then we can see the general expression for the homogeneous solution shown there. If we take only the beam-related degrees of freedom, we can combine the solution, the general solution of the differential equation, and a solution based on interpolating functions. And then we can obtain those interpolating functions which are influenced by the actual force that is acting on this bar element. And the expressions for these interpolating functions are given there. And how do we incorporate those interpolating functions in the P small delta effect? First, we removed the rigid body displacements and obtain a pure deformation state, and then we can calculate the bending moment at each section S, at any section, by simply multiplying the actual force F1 by the expression for the displacement V in terms of nodal rotations and interpolating functions. Using these interpolating functions, we can also obtain a tangent stiffness matrix which incorporates the actual effects, and the coefficients are shown there on the screen. Additional features implemented in Ftool. The first one we will talk about is the nonlinear version of Ftool, which was first shown in Rangel and Mata 2019, and it introduces a drop-down menu in which we can choose between linear elastic, buckling modes, vibration modes, and nonlinear analysis. When we choose the nonlinear analysis, there is a sub-menu in which we can control several parameters for the nonlinear analysis. This is previously done. What was done in this version was the incorporation of different options for geometric matrix, which use Taylor series, and you can see the reference Rodrigo 2021 for details regarding this formulation. And there is also an additional context menu which allows the user to choose between interpolating functions and the incorporation or not of the P small delta local effect. Some examples were formulated. Both bars in these two examples have the same parameters in terms of Young modulus, cross-section area, cross-sectional inertia, and length. The only difference between those two examples are the boundary conditions and the loading conditions. The first example is shown here, and we have on the left side we have the linear solution, the first order solution, and on the in the middle we have the non-linear solution, but without the P small delta effect. And on the right, we have the non-linear solution considering the P small delta effect. The right solution was obtained by marking the last item in the context menu shown on the screen. And here we can see that there is a big difference in the middle value of the bending moment by considering or not the P small delta effect. And in this other example, we apply bending moments at the ends of this bar, of this actually loaded bar, and by choosing by marking the last option in the menu, also we can see that the P small delta effect is taken into account, and there is a big difference between the value of the bending moment considering or not the P small delta effect. It's important to emphasize that all of these examples were implemented using one element per bar only. So the only way to capture this phenomena would be to discretize the bar with several elements, and which we did not do here. Some conclusions. Actually, basic interpolating functions were incorporated to a context menu in which the user has the option to turn on the local P delta effect when plotting the bending moment diagram. Since Ftool is widely used in undergraduate courses, the main idea is to use minimal discretization. Results indicate that the ability of the formulation to capture the P small delta effect successfully. Future works involve extending this formulation to Timoshenko beam theory and to problems with distributed axial load. There are some references, the main references used in this work. Thank you.